So, very quick introduction about myself. So I am Tug Grall. Tugdual is a Celtic name. I'm coming from France, and even in France, it's not a very usual name. So I'm working as a technical evangelist. That means I'm meeting many developers and system administrators, startups, to talk about NoSQL in general and Couchbase in detail. And before, work in another open source company named Exo and a non-open source company named Oracle for 9 years. So what is interesting is just I'm coming from a pure SQL background with Java mainly, but so if you want to reach me, you have some information. And I'm also maintaining a website that use Google App Engine to learn more about cloud deployment, cloud management, and Bigtable as another SQL engine. So I like to start NoSQL so as a not only SQL database about why relational databases are not necessary enough. So just a quick survey. How many of you are using a NoSQL something? A simple key value store, or which one? Just curious. Memcache. Who is using Memcache? Okay. Couchbase? Nobody? Mongo? HBase? Cassandra? Okay. So mainly key value and Mongo. So it will be interesting to see some information about the link between Couchbase and Memcache. So one of the reasons is this, is some new applications, and you can see that from a developer or from a CSOP, from a pure sysadmin point of view. In one night, Instagram moved to gain 1 million users, and the same kind of number or proportions, even bigger, in the number of pictures they have to put online. So Instagram is not running on Couchbase, but OMG Pop Draw Something is. And in 1.5 months, they moved from 0 user to 50 million users, from 0 images inside the database to 2 billion images inside the database with all the metadata. So if you look from your background as a relational user, relational database user, just think about how do you scale this? How can you you start small as a startup, typically. You don't want to invest with the biggest server, and you have to move to something a lot bigger very quickly. In this specific use case, they moved from a 6-node cluster in February last year to an 80-node, around 80 or 90, so 90 nodes cluster mid-March. So the way you scale relational database, they have been built to scale up. They have been built to add more and more CPU, more and more memory, more and more disk on one single machine. So you just, if you have more users, more data to store, you just take a bigger server until you have the limitation of your bigger server. If you look at the way we work on the middleware, most of the time, we have smaller machines, and we put many of them, the one aside of the other. And we add more and more when we need more power, when we need to deal with more users. And you also have to deal with load balancing. In some case, so this is not the only way to deal with scalability on relational database. You can do this kind of stuff. So meaning you still have your app server in a cluster. You add caching layer, so very often it's memcache. In Java world, it's a little bit different. And you have relational database. In this case, I use MySQL as an example. When you add many clusters or many nodes of MySQL. And here you have challenges. Not only it's not necessarily easy to add new node if you need more storage, if you need more power to calculate, to do the queries, but also most of the time when you do that, your application is responsible of doing the sharding to separate the data on different nodes. If you look at the way most of the users are doing cluster today, clustering relational database, they are doing replicated server. So they have many servers using the same data many times. So it's great for load balancing. It's great for high availability, but it doesn't help with sharing the data across multiple nodes. So leveraging smaller machines in a cluster, so having a less expensive layer. How many of you are using relational database in a cluster? And how many of you are doing partitioning? So you see it was typically the survey we had usually. So some of you are using cluster of relational database. None are using partitioning. And one of the goals of NoSQL engine, most of them, was to deal with that. And we didn't really build it from scratch. When I say we, it's Couchbase, but all other vendors of NoSQL engine. It has been built on the experience of big internet website. Google, Amazon, Facebook, and LinkedIn, they have many users, many data, and they continue to grow all the time. So they had to build data stores. They had to build a persistent storage where they can do auto-sharding, distribution of the queries to be able to use all the servers they want to when they need to, but also, and it's something that was interesting, kind of move away from a pure schema-oriented data layer. And one of the reasons is they want more flexibility to move new application in production, new version of the application of production. But also, they want to be sure that they can update the data without impacting the existing data. Because they have billions of data, they don't want to do an alter table that could have an impact on the running system because they have to touch many records inside the database. So instead of having you, your team, your company building the NoSQL database using this, you can either take some example of Cassandra, Voldemort that are accessible, or take another project. In this case, for example, Couchbase has used some of the paper that has been published here to build the new database. And the goal is to have the same kind of architecture on the persistence, on the database layers, than you have on the middle tier. You need more users, you add more servers. You need to distribute more the load between more servers because your existing cluster is too small to handle all the write or all the reads. Add more cluster. Armored node to the cluster. In this case, you have a similar cost for the middleware and from the database layer. So you work on smaller servers and you add more when you need to. Or you can reduce also the size if you have some peak of activity. We did a small survey to our community. So this is something we have done inside the Couchbase community. We asked them which feature or which capacity do you like, or why do you go to NoSQL? Do you do because the cost, because of the performance, the scalability? And what was interesting, it was mainly because of the lack of flexibility of the relational database for their application. And we see that because more and more applications are aggregating applications data from everywhere. You want to capture data from your CRM that is coming from Salesforce or your internal CRM system. You want to aggregate data coming from the internet. You want to capture and make a link between some Twitter about your company and some internal data. They have no format. They have no schema that you can control because it's coming from applications that you don't necessarily control. So store the data as they come inside your system, build the application at the top of it, and you can add more value to this data, was one of the reasons. Flexible schema is quite interesting for them. So how do we I will just now go to how we have done it with Couchbase, but you can kind of extrapolate that in other NoSQL engines that has been built to scale out, to be distributed on many nodes of the cluster of many nodes. Not all NoSQL engine has been built for that, but it's a case of Couchbase, Cassandra, Mongo, HBase, for example. First of all, it's an open source project, so use it as much as you want. We have an Apache license, we have an enterprise edition. It's how we make money. We have some customer paying for support, but we have a community version that you can use as much as you want. And we focus on 4 things when we build the product. Easy scalability. We want to be sure that when you are in production, if you need more power, it's easy to do. You don't have to change your application. You don't have to work on a new partitioning key or a way to work on the replication. You just add node to your cluster. So as a system administrator, a script, a console, you add nodes, or you remove nodes the same way. Because we are used to deal with a large volume of users most of the time, or a large volume of data, we want consistent performance. And it should be true in a 2-node cluster, a 50-node cluster, or a 100-node cluster. So we have been working a lot on this to be sure that when your application grows, you want to be sure that the performance stays the same. And I will explain quickly how it's done. If you build application that is available on the internet, you want to be sure your application is always on, including when you have to do major update or upgrade of your system. And one of the key components of our system is you can upgrade the version of your database, including a major version coming, for example, from 1.8 to 2.0 without stopping your database. The way you do that, you add new node to the cluster in a new version, you rebalance the data, you remove the old nodes, and it's done. You are in a new version. And a big part of our QA is done about this. Performance and always be on, including during upgrades. And we talk quickly about the flexible data model. Couchbase is used by many companies. Oops, sorry. I won't go in the details. They are used as a simple key value store, fast cache or distributed memcache, database using JSON document and queries depending on the use case. We can discuss that later if you want. So how do we build the product? It's a database and it's distributed. So we have two main components inside the database. Data manager, cluster manager. Each of them have a specific responsibility. The server and cluster manager is written in Erlang. And the goal of this is to keep all the nodes communicating together to be sure that the cluster is alerted when one node is dead or when we add a new node. All the persistence has been created in C. So to have append-only file for indexes, append-only file for data file, and this distributed on different nodes of the cluster. And we also use JavaScript V8 engine to do the query. Since we are not in a developer community, I won't go into the detail of all the query, how it works, and so on. But from an administrator point of view, you just have to open some port to have all the nodes of the cluster communicating together. And if you look at the top, we have 2 interesting ports, 11 to 11 and 11 to 12, that are memcache protocol. Because the way you access the data inside Couchbase is using memcache protocol. In fact, the cache we have here, it's memcache. Couchbase is one of the big contributors of the memcache product, of memcache project. We include memcache in our database as a default caching layer. And one interesting part about that, you can replace any memcache project using Couchbase to have a distributed and managed cluster of cache. But in addition to that, that means because we have the persistence on disk, you can store in your cache more data than you have RAM size. So it will automatically save the data on disk, continue to work with the keys in memory to be fast, and when it's needed, the data, get them from disk, move them up to the memory. So if we look at one single operation, and I'm just showing that on a single node, if your application needs to write some document on some content inside the database, the client application will just go in the cache, put that in the cache, very, very fast. It's memcache, distributed. Then, on an eventually persistence way, so eventually the thread on the server side will take this document, save it to the disk, and send it to the other node of the cluster. So you choose as a developer, and this is the choice of the developer based on the critical path of the application, if you want to do the saving asynchronously or synchronously, just to be sure that you save the data. I'm saying that from an application point of view. If you want to wait, your application wait just to be the document be in memory, it will be very, very, very fast. Or a little slower because you will wait, it's saved on disk, or replicate it to another node of the cluster. And one of the big differences between NoSQL engines and relational database in this case is the developer has control of how much operation he wants to do. Do I want to just put that in the cache? Because it's in a cluster, I will say, OK, I believe it will be saved later, so I just can input many, many, many data in my cluster without waiting for any persistence or any business logic. So no update on the index, no global transaction management, just fire and forget to be very, very fast. We have, for example, a project. It's on the 20-node cluster. It's 650,000 operations per second with 20% of write or update. You don't want to wait too much when you do that, especially if your application is OK to have eventually persistent stuff, meaning you don't get the data immediately. You have to wait sometimes when you do queries that is saved on disk. So you have a kind of a mindset change when you work with NoSQL engine. One important part about distributed system, we don't copy the data on all the nodes. What we do, you have the documents that are distributed evenly on the different nodes of the cluster. And the application knows what is the cluster map, what is the topology of the cluster, and will automatically be updated when you have some change. And because you distribute the data on the different nodes of the cluster, you have replicas to be sure that if one node dies, you still have a copy of the data you can use. Here, we don't copy all the data on which node. We just distribute the data to be sure we can scale and we don't take too much power and too much storage. But we do copies depending on how much confidence you have inside your cluster and inside your machines. So you have the replicas inside Couchbase, and this is a choice inside Couchbase. Some other NoSQL engine will work differently regarding replicas. You have one single active document in the cluster. And the application will always go to the active document when it needs to access it. And this is a client library that will choose on which node you have to go using the same algorithm that you have on the server to say, where do you go? So if I want to read and write a document, I will go on a specific node using memcache, and I know on which node I have to go based on the key. This is why we have the consistent performance when we grow the cluster. And because all the applications, all the nodes in the cluster from an application point of view for a specific document will always go to the active document, we are consistent when we write, we are consistent when we read. You don't read the replicas. Because when you read the replicas, you may have some consistency issue if the document has not yet been replicated after an update. So this is a choice of implementation. So we choose to be consistent using a single copy, a single active copy at a specific moment of time. So how do you add nodes to the cluster? As a system administrator, you have a command line interface, you have a REST API, or you have the UI, and you just need to install Couchbase on one or multiple nodes. When you are ready, so I want to move my cluster from a 3-node to a 5-node. When you are ready to do that, you just ask the system to rebalance the documents on the new node of the cluster. So now, instead of having the documents distributed on 3 nodes, it's on 5 nodes. This means more write operation per second, more read on a bigger cache, because you have added memories on all the nodes. You have 2 nodes with the same level of memory. And automatically, during the rebalance, and when you add nodes to the cluster, we update the application with a new cluster map. You don't have any master or any slave inside this architecture, because the algorithm we use to distribute the data when we do the rebalance is the same that we use in our client SDK in Java, PHP, Ruby, and so on when you build an application. So if we compare that to memcache, this is, you can imagine to have memcache on each node, but we distribute the data for you. It's not a cold cache, so if one node dies, we have the data on disk, we can get back them very, very quickly. What happened when a node failed? When you do a distributed system, especially on small or commodity servers, failure is part of the story. We have some customer running on Amazon, and they have a 20-node cluster. Every month, they have at least one machine there disappearing from their cluster, either because of network issues, or just because they want to upgrade, or just because they have issues with Amazon. So in this case, what's happening? Your application is working, and for whatever reason, the server number 3 dies. Could be a network not accessible anymore, or just the disk fail, or memory fail, or the OS just crashed. In this case, we just promote the replicas as active without changing anything. So it's very fast because the documents are already here. And the application knows and now that they have to go on these different nodes to get the data. And the system works as usual. This operation of doing the failover, moving the replicas from replicas to active, it's something that could be done automatically or manually. It's interesting to see that on large systems, it's something you do manually. The sys administrator are responsible to do the failover. And one of the reasons, it's because you want to know what's happening inside your system. Why this machine is not available anymore. If it's a network issue with a switch that has died, you may have more than one machine that is not accessible. Suppose you have 3 machines down, you can do a failover. But that means your system, instead of working on 5 servers, it will work only on 2 servers. Maybe 2 servers is not enough to get the workload, to get the load of the users that you have. So this is why in big deployment, the failover is something that is done manually or manually by scripts on this stuff, but something that is controlled by the system administrators. So what I like to do now is I like to do a small demonstration of how do I add new nodes to my cluster. So what I have here is I have a cluster on Amazon, so I'm using Rightscale just to manage my VMs. And I have 6 nodes, 4 nodes with Couchbase up and running, 2 nodes where Couchbase is just installed but not part of the cluster yet, and 2 other nodes that are just injecting queries, so doing some stuff on my database. If I look, when I connect to the system, I have a console, and everything that I do here, it's available using an administration command line interface or a REST API. So I see the global RAM of my cluster, the global usage on disk, the number of operations per second, so I have around 7,000 operations per second here, and the size of my cluster. I have 4 nodes, and everything is up and running. I can take any node of my cluster and connect to the console. So if I take one of them, I will take this one. And I will connect, and I will have exactly the same view on my cluster. Amazon is sometimes not that fast. So here I can go and navigate in the different tabs to have more information about my cluster, which machines, which OS, what is the versions, because as I said in the past, to do the migration, we can mix different versions of the product. So here I see exactly which version of Couchbase I am using on this node. So a single view of my cluster. If I want to add new nodes to my cluster, what I can do is I go to a node where it's installed or not yet configured, and I will just take the IP address of one of the nodes of my cluster, and I will say join this specific cluster. So here I'm just adding a node to the cluster. I'm not doing anything yet with the data. So the server is part of the cluster, but the data are not yet duplicated. So I'm on 64. So I will take another node, this one, another node where the database is not yet installed. And I can do the opposite. I can start from an existing node. So I will go on this node, and we'll add a server. So now it's just gathering information about the different cluster. So I'm still a 4-node cluster, and I see that I have 2 nodes waiting to be part of the cluster after the rebalance. And I can remove nodes the same way. And what I will do now, by doing rebalance, it will just use the algorithm to copy the data from the 4 node to the 6 node. And while doing that, the application is still working, the data are still accessible. And what's happening is the client, in this case it's a Python application, it's alerted about what's going on the server. Give more information about this new node is available, the data has been moved from this place to another. And if in one case, my client application is trying to get the data on one node, and it's not yet available, they will know on which node he has to. He will say, the server will say, this data is not available on this node, so he knows that he has to go to the new part of the cluster. So depending on the size of your cluster, the speed of the network, you will see more or less impact on the operation per second. But here, during the rebalance, we move from 7 to 3 operations per second. If you have a fast network, it's Amazon, so it's not the fastest network on the planet. You will have better response times. But the important thing, we don't have to stop anything. The application is still working. Writing, reading the data. Any questions? So adding the data to the cluster, it's done.
The data sizes seem to be quite small.
Yeah, this is small here.
But it takes quite a amount to rebalance it.
So first, it depends. Yes, in this case, it's small. We are on not optimized network. It really depends on your data set. But we have to keep in mind, if you have, for example, like some of the sites, we have 1 billion keys. You don't have 3 nodes or 5 nodes. You have a lot more. And the distribution on the rebalance will depend on this. But it could take some time. Really, when it's big, it could take up to 1 hour to rebalance all the data. But the data are still available for your application. So this is an important part. It doesn't impact the running system.
So it's somehow limited, or?
No.
The rebalancing progress seems to be limited somehow, that the data is still accessible.
It's not limited.
No, I think the question is during the rebalance,
yeah.
I think on physical hardware, you're going to pump all data through the Ethernet device, and the Ethernet device has just...
Not all the data. It's a subset of the data. But you will have, at the end, you will have to distribute all the data. So yes, you will have CPU on network, I/O on network access.
The interface is full of to be replicated data. How is it still available? I think this was the question. Is there some limitation?
So the thing is, we always focus on giving access. This thread reading the data will always be the priority. And if you want really to separate on 2 Ethernet, 2 network connections, this is the way you will work in this case. You will configure different connections for replication and rebalance beside applications.
Okay.
So in addition to querying by keys, if you build application, you also have indexes. So we build indexes and we distribute the indexes using MapReduce. So meaning every time you update or modify a record, we update an index locally on each node, and we distribute the same way. We have distributed the data, the index. So when you query the data from your application, you don't query the full database on one specific node. You just distribute the query on all the nodes of your cluster. So when you need it to, one node will be selected, scatter all the query, gather back the data, so scatter and gather, to reply all the queries. So this is pure application logic. As a system administrator, you have to know that you have an index on this. I will take some space, and you can choose or not to have a replicas. Because as you mentioned, if I choose to have a replicas when I do the failover on the rebalance, I have to distribute the data. Sometimes what we do, we don't replicate the index, and we let the index be updated after the failover. So one important feature is always about speed and also the way you want to distribute your data or use your data. It's a cross-data center replication. So when you have one cluster, for example, in New York, and you want to, for either a backup or to have a copy, a running copy on the West Coast, you may have two clusters of Couchbase, and you will just put together the cross-data center replication process that is taking some nodes, and it could be a different number of nodes on each cluster, and every time you will have an update of your data, you will send the data over the network to the other part of the cluster or to the other cluster. This is done asynchronously. And we manage conflict in the way that we do the algorithm to check the content, and in this case, we calculate the last one kind of based on the algorithm, and you will win. So we don't do merge of the data. So depending on the logic, you can have specific set of data on what we see with, for example, social gaming applications. Europe, US. In Europe, they will have a specific set of users that push the data this way. In US, the other way, but there are different documents, there are different profiles. So in this case, you can avoid conflicts between the data, so your application will be easy to work with. So you can do either bidirectional replication or in a single directions to one cluster to another cluster, depending of your business logic. This is based, in fact, on the REST API we have under the scene. So it's based on HTTP. So one important part when you select a database, it's how do you size, how do you monitor what is in production, how do you scale, and be sure you can continue to scale when you have a successful application. And we have a simple rule that it says the sizing of your cluster, what it will be the result for the performance of your cluster, of your database. So ideally, you should find a way that you know enough about your data set. What is your working set? What is the size of your data your application is using? Not necessarily the full data set. You may, if we have a big difference, for example, between social gaming, you may have 10 million of records, but you only have 2 million of records that I use at a specific moment of time. At the opposite, we have advertisement or ad targeting platform. When you have 10,000 or 20,000 of data, all of them should be accessible immediately because you need 30 milliseconds to make a decision. So depending on this, you will size your cluster. And one of the key points is you want to be sure that you try to have enough memory to work with your working set, and be sure that when you have a lot of write, you have enough servers to deal with all the IOs you do. Because every time you will have a queue that is filling up, your system will slow down. So all the monitoring of Couchbase, it's about dealing with this. How the network works when you do replicas, how the disk work when you work on when you look on getting the data in and out of the database. What is the cache miss inside memcache when you work with the data? So one of the key points is before tuning too much each system, most of the deployment are just adding new nodes to the cluster. Adding new nodes will add more RAM, will distribute the write on the read on more disk, and will automatically give you better performance to the system. And I was thinking about the I/O to the disk. And it's quite important, if you know your system, to see the impact of this. We have a project that is doing ad targeting, and especially what they do the metadata to select which ad you want to see, or you have to see before looking at a YouTube video. You don't necessarily want to see it, but you have no choice. So the deal when you work with Google on this, between the moment Google asks you to show you, to give you, to ask you to give you the metadata about the video, you have 110 milliseconds. This specific project is running on Amazon. That means between the network latency, the access to the database, and back, they need to access the good metadata in less than 30 milliseconds inside Couchbase. So it's a Java application calling Couchbase, and in less than 30 seconds they have to do that. They have 1.2 billion of data inside the database, so user profiles and campaigns. And the way they do that, every week they upload a third of this data with new values. They have calculated that in Hadoop and all this stuff. They extract the data from Hadoop. They inject a third of this data inside the database. So for a specific moment of time, they need very, very fast write operation. And what is interesting for this project, they're using Amazon. They have two big data centers, one in Europe, one in the US. For the same volume of data, 20 node cluster in the US, 7 node cluster in Europe. Do you know why? Just because the Amazon data center in Europe allow you to use SSD drive. So a lot faster to write. So when you do a batch operation, this queue will be a lot faster to write on disk from your memory compared to the one with mechanical drives. So when you want to size a database, and it's true for NoSQL database, but for Couchbase, but it's true for most of the NoSQL database, and I will say it's the same when you work with a relational database. Always look at the RAM, and based on the RAM, it will be based on your working set. And this is a key point, is most of the time when people are asking us, when they do a POC, how many nodes do I need? We just ask, what is your working set? How many write? How many read? Do you add data every time? Do you have expiration of your data? Because you can say inside Couchbase, store this data, remove it after a week, or remove it after 5 minutes. So understanding the life cycle of your data is key, because we can size properly the RAM, how many write, the disk, and if you don't have enough RAM, we will have a lot of cache miss, meaning we will read more from the disk, queuing, waiting, so it could be an issue. CPU is used intensively when we do queries for indexing and when we do rebalance, because we have to read and push and recalculate the index. And network is quite heavy when we do rebalance. On a normal use case, we don't consume that much network because we know where we have to go, and we just replicate a subset of the data. And the data distribution and safety, it's more how many replicas do you want inside your cluster to be sure that if we lose 1 node, 2 nodes, or 3 nodes, X node in a specific moment of time, you don't lose any data inside your cluster. So we have specific formula that help on the sizing based on some input you give about your working set. But when you select an NoSQL engine, not only you have to understand how do you size the cluster, because usually having a one single node NoSQL engine, especially when there's been to be distributed, doesn't make sense. So how many nodes you have is quite important. But a very, very important part that, especially when the developers are choosing the solution, they forget about how much work do you have to do when you are in production, when you have a failure, when you add some nodes to the cluster, when you want to add or remove nodes based on the workload or based on the success of your application. Always try to think about how many nodes do you need to do today and what will be the life of your application. So inside the administration console, you have many stats. All these stats are also available using the command line. And we kind of give you a quick update on the console about which node or which statistic you want to see. You want to check as a system administrator operation per second globally, write and read, cache miss. Obviously, if you have too much cache miss, if the cache miss ratio is too big, that means you either have not enough memory or you never reuse any data you have inside your system. Create and update per second. Disk read. So how many times do you go to disk? And one that is very important is a disk queue. So if this one is filling up too much, that means it's you're injecting a lot of data and we don't have time to really go very, very fast on disk. If it's staying up, even if you can tune with some parameter, most of the time adding new node to the cluster will solve that by distributing the read or distributing the write on new node of the cluster. So this is another the same kind of view. So this is the kind of stats you see when you are connected to the system. As a system administrator, if you want to connect to a system, I don't have Couchbase running on my. For example, for people that are familiar with Memcache, you will have many, many stats that give you information about how do you want to monitor the system. So we have people that just monitor these stats, integrate that to Nagios or other tools to see if the server is up and running, if they have some specific actions to do. If not, you can use our command line interface or the REST API to get the data. So we are a database. So a big part of the database, even if we are distributed, and most of the time you don't necessarily stop and you don't necessarily have a lot of administrative tasks to do, you can back up and restore your data. So depending on your system, on the way you do it today, you can, for example, use a CB backup, so Couchbase backup, that will take all the data from all the nodes and create data file of this specific data. Some other approach is, instead of using the CB backup, you can do, so CB backup will allow you to back up the data and not necessarily restore them in the same cluster, same size cluster, same kind of configuration. But you can also, if you want, back up only the file. But in this case, you have to have exactly the same configuration when you want to get up. So CB backup and CB restore. And interestingly, when you need to have a cluster and you want to have kind of a standby, so a cold cluster, you can just use a cross-data center replication. Concur.com, that is doing a web expand system, they are using Couchbase internally, and they have two data centers. One that is in production in their own data center, and the way they do backup, and they also use that to have kind of integration data, they use cross-data center replication to push the data from their production website to Amazon. Like that, they always have a copy of their database ready to go in case they have an issue with their own data center. So backup using CB backup, CB restore, using file system, or using cross-data center replications are the different options you can have as a system administration. So do you have any questions? Yeah?
Regarding the cluster maps, can you have or do you have any influence on the cluster map? So you mentioned that earlier with those two data centers and US West and US East. So that you have this asynchronous replication. So for me, the question is, yeah, this no, the other.
Yeah.
But is there also also a possibility to just have one huge cluster, which is a West Coast and East Coast, but you can define that, for example, each document has to be in each data center once?
So the short answer is no. A cluster like that has to be on the same data center.
Okay.
And you as a developer or the system administrator, this is why I was showing the two slides, you don't have any impact today on the way we do partitioning. And one of the reasons we do that is we want to keep the life simple for the developer and for the system administrator. And one of the reasons is if you start to, it could be possible. We have some prototypes that we have done that when you can prefix a key to say all the keys that name US will go to this side of the cluster on this side or the other side of the cluster. And I'm talking about the single data center cluster. The issue is if you start to have this, you may have a totally not balanced cluster in terms of volume, and you may have issues if you have failover to do and rebalance to do. So this is for a single cluster. If you are running inside this, so two clusters communicating together, well, on one single node, it's very fast. We use memcache, we use internal protocol to communicate between nodes. Here we use HTTP. We don't have consistency of the data between this and this, because you have to have the replication that has been done from one cluster to another.
But I see a problem, you already told, in terms of concurrent writes on the same object. So
you only have concurrent issue on the same object if you are in this situation. On this one, you don't.
Yeah, I know, because you only have one active copy
Yeah.
of the document.
Yeah.
But on the other solution, so on the distributed solution, you will always have problems with concurrent writes.
So-
Same object, or?
So today, the people that are doing most of the time the cross data center replication, they work in the way that they don't have this kind of issue. They use really the distribution, they don't really use the distribution. They use a cluster in a way that they have specific data on this data center, other on this way. They can replicate in both ways, but this application here will only connect there in case of failure of this specific part. Yes, if you have exactly the same documents, for example, you want to change your user profile, and you are connected here and here, yes, we have issues. We have to manage conflict, and today the way we manage conflict is Couchbase doing it for you, logging some exceptions when we have issues. But one important part, on a single cluster, we don't have any consistency issue. You know, because this is so neither in write or read. Because depending on the NoSQL engine, it could differ. You have many NoSQL engines that are not consistent when you read the data. Other questions? Yeah.
Just a second, please. We need the microphone for the recording.
Yeah, sorry for that.
Is it possible to split the core, for instance, the memcache on another node than the data module?
No, today it's part of, so one node is a set of memcache plus the data layer.
Also the index. So I'm not able to split it on different nodes and have one big index
No, because you don't want to have one single big index. It will be too hard to update and read.
Okay, no, just for instance, that I have multiple machines with a lot of cores, and some machines with more memory, and some machines just for data store with a lot of hard disks. And I think it would be great to have the ability to split them.
So what you can do, from a disk point of view, you can split the index on the data, but the process that are running in memory or writing on disk are on the same machine.
Okay.
Any question?
One of the shortcomings of Memcache is that while it is distributed, it doesn't replicate data. So in a normal setup, you always have single points of failure. Couchbase does mitigate that, and my question is, what do you have to do to replace Memcache with Couchbase? And are there any changes I need to do on the client side?
So, as I said, what we do, we distribute the data. So I will just show you one thing. When I create a new bucket, so a new database, I have the choice between Couchbase and Memcached. So if I select Memcached, I have a cluster of Memcache that is managed by Couchbase, but we don't distribute the data in this case. We just have the same as what you have today. We just make the life easier for the user. When you use this Couchbase, this is what most of the people are using. We use Memcache protocol. It's what you see from your application, and we distribute the data. And we replicate the data, and we go over on disk. So what do you have to do in both cases? But I will say this one is the most interesting. For your application, by default, you can move without changing anything. Because what's happening is we have something we call Moxie. So it's a Memcache proxy that is part of the server, or you can install that locally on your different application server. And you connect to this. And this Moxie will be responsible of, based on the key that you send to know where on which node you have to know, it will be alerted if you add new nodes. So it will be typically, Moxie will be this kind of stuff. So this is the first step. So in this case, you don't have anything to change. You use any Memcache client you are using today. You just have to be sure that the IP address on the port is good. But if you want to avoid this small hop you have to do on the network or locally on the process, you can change then your application to use our SDK. And in this case, your PHP, Java, Perl, or C application will be directly connected to the server. So most of the time, people that are moving from Memcache to Couchbase are telling the first solution first, Moxie, quickly, nothing to change. And when they start to leverage Couchbase as a database, they start to use the client SDK in their application. Any other question? Okay, thank you.